Hello guys, now we have a little problem here. If you take a look at our character here, we're going to hit the play button and we can run around and sprint and stuff. But if we walk off the ledge here, we just kind of float down, and that's not what you want as a response to jumping off of a ledge or balcony or any heighted area. So in this episode, we're actually going to add falling and landing to our character. So I got these falling and landing animations here. I got off the Unity asset store. You can find a bunch. They're almost everywhere, usually in locomotion packages. And I'm just going to drop them here in the animator, but first we're actually going to make a new layer. So this layer is for our locomotion. That's all fine and dandy. Let's make another layer, and we're going to call this override. And this layer will be used to play animations that basically aren't locomotion. So any actions you're performing, like opening a door, dodging, falling, landing, attacking. And we're going to create an empty state here so that whenever you're done these actions, you come right back to the state, and then you transfer back to your locomotion state, which is on the layer above. Because this override layer will override the animations of the locomotion, and then when they go back to the empty, it will send them back to the locomotion layer. Now you actually don't need to make this transition. The only important transition is making a transition from land to the empty state. I did this on camera by accident because I was testing something. So again, the only transition you need is the transition from land to empty. So I'm going to check foot IK here on the landing animation, so it actually locks our feet to the ground when we play the animation. Now under parameters, I'm going to add a bool, and the bool is going to be for the Animator Manager. So let's open that up. Before we do that, let's actually go into the Animator Manager and make the function public void play target animation. Now this function is going to play any animation that we wanted to when called. So we're going to use two things up here. We're going to have a string, and it's going to be the animation name. We're going to call that target animation. And then we're going to have a bool, and we're going to call that is interacting. And this, think of this as the bool that means, are you locked in this animation? So if you are interacting, then you can't move around or rotate or control the character. So you're locked into some kind of interaction. Now we're going to say animator.crossfade, the target animation 0.2f. And that's just going to crossfade into the animation that you just selected from the one we're playing right now, and it's going to play it. And then we're going to say animator set bool. We're going to say is interacting. And then we're going to say is interacting. So we're going to change the bool on the animator that we're going to make right now called is interacting to whatever the is interacting status on that bool is when you call this function. So let's go up here and let's make a new parameter, a bool, and we're going to call it is interacting. Next, on the player manager, we're going to go ahead and make a public bool called is interacting. And then on the late update, right below where we handle the camera's actions, we're going to say is interacting is equal to, and we're going to need to call our animator up here. So let's do that right under the input manager or camera manager or above it all, whatever you want to do. We're going to declare it and then call it on awake. Since it rests on the same game object as this script, we'll say get component. And then right below here on late update again, we are simply going to say is interacting is equal to animator dot get bool, and then we're going to open up these brackets here, and we're going to say is interacting. So basically, every frame we're checking for that is interacting bool in the animator, and we're going to change this bool to whatever the one on the animator is. And you're thinking to yourself, well, why are we doing that? And I will show you momentarily. It will make sense. Don't worry. So now, we're going to stop our movement and our rotation while we're interacting. So we're going to say if player manager. Let's go ahead and call that up here first. So let's call the player manager script right above the input manager. On awake, let's just say player manager equals get component player manager. Again, because it is resting on the same game object as this script. Get component player manager. Okay, good. Now, down here we will say if player manager dot is interacting, then we're going to return. Basically, that means we're just not going to run the code below because we don't want to give our player the ability to move or rotate while you're performing an action like falling or landing or maybe attacking or dodging. That would look really weird. All right, let's save that. Now, over here on the empty state, this is why we need to put the is interacting bool on the animator. We're going to add a script onto the empty state itself. We're going to call this reset bool. So every time we perform an animation, like falling or landing, when the animation is done, we want to reset the is interacting bool on our animator so we can then move again. Because if it resets on our animator, and then it resets on our player manager, and we are then able to move our character again. So erase everything except for on state enter, and then just delete these little lines here, and we're actually going to utilize just this functionality. And this is called every time the transition of the state from the last animation enters this empty state. So when you're done the landing animation and you transfer back to the empty state, this will be called. So let's make a public string. I'm just going to call this. I'm going to call this is interacting bool, and then let's make a public bool, and we can call this is interacting status. And then we can just say animator.setBool is interacting bool is interacting status. And in the future, if we have more bools we need to reset, we can just add them to the script if need be. So basically, when we come back to the empty state after we're done playing our animation, we then reset the is interacting status to false, which will allow us to move again. So let's just fill it in right here. In the is interacting bool, we're going to say is interacting, and then we're going to keep that blank, or false, sorry. So when we come back, it will change the is interacting bool to false. I hope that makes sense. So now that we have that done, let's actually start our function to handle our falling and ground checking. I'm just going to call this private void handle falling and landing. Then right above here, we're going to say handle falling and landing. And the reason we're saying that above if is interacting return is because no matter what's happening, we want our player to fall if he falls off a cliff. It doesn't matter if you're performing an action or you're attacking. If you fall off a cliff, you must begin falling. So we're going to say raycast hit, and then we're going to say hit. So we're having a raycast hit variable here. And we're going to say vector3. This is just going to be the raycast origin. So where the raycast is going to start in the game, where it's going to basically shoot from. And that's going to equal transform.position. So that will be at the feet of the player, the very, very bottom of this game object. Because this script rather, is placed on the same game object as the player. So this will actually start the raycast right at the bottom of the player's feet. Now, we're going to make a header up here called movement flags. And I'm just going to make a public bool called is grounded right below is sprinting. And this will tell us if we are touching the ground or not. So next we're going to say if we're not grounded, so if exclamation point is grounded, which means if we're not grounded, if is grounded equals false, we're going to say if player manager dot is interacting is not interacting. So if they're not interacting and you're not grounded. So if you're in the air and you are not doing any kind of action, then we're going to make the player play an action, which will be the falling animation. So we're going to use the animator manager here now, and we actually need to call that first. So right up the top, right below the player manager, let's just say animator manager. Not sure why my input handler did that. It's going to hit tab there. And on the awake method, we will call that. And again, it rests on the same component, or the same game object rather, as the script. So we'll use get component. And then down here, we are going to say animator manager, and then we're going to use our new function that we just created. So we're going to say animator manager dot play target animation, and that animation will be falling. And true, because we are interacting and we don't want to be able to break out of this animation until it has completed. So we can't move or rotate or run while we're playing this animation. We're stuck in this animation until we either transist out of it or something else happens. Okay, so we're going to add something else up here now as well. We're going to say header. I'm just going to call this falling. This will be all the settings to do with our player falling and in the air, etc., etc. We're going to make a public float and call it in-air timer. Now we're doing this for a couple of reasons. Normally when an object falls, it doesn't just shoot to the ground immediately. It falls, and as it falls for a longer period of time, it picks up speed. So we're going to use that here, and we're going to say in-air timer equals in-air timer plus time dot delta times. Every frame you're in the air, this air timer is going to go up. So then we're going to say player.rigidBody. We're going to add force to your character now. And we're going to add the force from his transform.forward first. So if you go to walk off a ledge, we're going to give him a little bit of a boost. He's going to almost jump off or leap off. So we're going to call that leaping velocity. So we're going to multiply some force by a leaping velocity variable, which we have not made yet. And then we're going to say player rigidBody dot add force. And then we're going to say minus vector3 dot up, which just means down. It's going to pull you downwards. And then we're going to times that by the falling speed, which we have not made it either. Don't worry about that. We're going to add those momentarily. And then we're going to times that by the in-air timer. So the longer you're in the air, the quicker you are going to fall. Okay, so I hope that makes sense. Again, minus vector3 up just means down, and we're going to multiply that by the falling speed and our in-air timer, and our leaping velocity, we're going to make that as well. We're using a leaping velocity, so when we come off of a ledge, we don't just like fall straight down. We almost pop off a little bit, so it's almost like you're just taking a step off of the ledge instead of just falling immediately the second you come off the ledge, which makes it look a little bit more natural. I'm actually just going to call this falling velocity to keep the naming space or the naming conventions the same. So now we have a falling velocity and leaping velocity float variable set up. Next, we're going to say if physics dot sphere cast, and all this does is it creates an invisible sphere around your player, and we're going to use that around the raycast origin. We're going to make it 0.2f for its radius, and then we're going to say we're going to make it minus vector3 dot up. We're going to make it out, and we're going to use our hit variable, and we're going to cast this on a thing called the ground layer. We haven't made that yet. So what that means is, let's go up here first, and let's make a public layer mask, call it ground layer. It means it's only going to detect things on this layer. So in short, all this does in simple terms is it creates an invisible check. It's an invisible circle or sphere around our player's feet, and if it senses something that has the ground layer, then it's going to be like, ah, yes, we've detected this thing. It has the ground layer. And then if that happens, we're going to do some logic. If we detect the ground layer and we are not grounded and we are not interacting, well, then we're going to play the landing animation, because now we were in the air and we detected the ground. So let's play our landing animation, and then we're going to set that to true because we are interacting and don't want to come out of that until it's done. And then we're going to say in air timer equals 0 to reset it. And then we are going to say is grounded is equal to true. Very simple, very straightforward. Else, if you don't detect the ground, then is grounded equals false. And then you're in the air. So, I hope that makes sense. Let's save that now. We have to do a couple more things, and then we are finished. Okay, so I'm going to put my leaping velocity to 3 and my falling velocity to 33. And my ground layer for me is default, because if you click on anything in the scene that I have here, as you can see, the layer is default. So when you bring these models into the scene, they're going to be on the default layer usually. So I'm also going to check is grounding. You don't need to, but it will check itself when it detects the ground. I'm just going to for the sake of it. We have to do one more thing now. Let's go right under vector3 raycast origin. Let's say raycast origin dot y is equal to, and I'm going to make another variable here, raycast origin.y plus, we're going to say raycast height offset. And the reason why we make this, and I'm going to make this variable up top as a float, I'm going to initialize it at 0.5, is because if we don't, then basically the raycast is starting below the ground, because we're using a plane right now, and it's starting below the player's feet, so it's missing the plane. So instead we're going to start it a little bit above the player's feet, so the sphere can detect what's at the player's feet. I hope that makes sense. Now, if we jump off the ledge, we fall, but we don't play the animations. So you're saying, oh, what's happening there? Well, this is a very simple fix. You have to go to the animator. As you can see, the base layer here, it has this little cog. You can check the weight. It's stuck at 1. Now, the only way the override will work is if the weight is at something slightly high or around that area. So we're going to set it to 1 because we want the override to completely override the animations of the base layer. So let's crank that all the way to 1. Now, if we go back into the game and hit play, as you can see, we're going to run here now. We're just going to take a step off this ledge, and we play the falling animation, and there's the landing animation. It looks great. Very simple and very straightforward. I hope you guys enjoyed this video. If you did, please drop a like, leave a comment. It does help appease the YouTube algorithm gods. It does something to the algorithm so other people see this video. If you're feeling super generous, check out my Patreon below. In the next video, we're actually going to work on jumping, and we're actually going to add a couple more things to this falling system in the future, where you will only display the falling animation if you've been falling for a certain amount of time. You will only play the landing animation if you've been falling for a certain amount of time. We'll add like a soft land and a hard land. We'll basically expand upon this in future videos, but right now I want to go through and lay out the groundwork for all the functionality I want to put in. So again, I hope you guys enjoy this video, and I will see you in the next one.